you all for coming out to the deck lunch today. We have deck engineer Cody Hutchens, who's going to take us under the hood with Alexa.
Thank you. Can everyone hear me okay? Does it sound okay? Just want to make sure I'm good. I'm not blowing anyone's ears out or anything like that. Alright, yeah, so I'm going to go into what Alexa is. Does anybody here, does anybody have an Echo Dot or an Echo of some kind? Awesome. Awesome, yeah. So, okay, so you guys have probably had some contact with Alexa, and you probably heard about it at some point in time on the news or whatever the case is. But my goal today is to talk to you about Alexa and just kind of give you more of a better understanding technically what goes into building what they call skill for Alexa, and how it all fits together. So I wanted to start off with something kind of funny. I found the statistic yesterday that it has over 250,000 marriage proposals already to Alexa. I thought that was kind of funny. I was like, doesn't surprise me, I guess.
So we know there's at least 250,000 losers in this country.
Yeah, you want to think about it that way, yeah. So yeah, I thought I would start off with that. I thought it was kind of funny. Anyway, so the question is, what is Alexa? That's what I want to get to. And Alexa, according to Amazon, is this. You can think of it just as a cloud-based voice service. So they give you the ability to talk to something, and it will convert it to something useful for you to act upon, I guess. And it's cloud-based, so you could connect it theoretically to anything. You wouldn't need just like the Echo Dot or the Echo. So yeah, it's a cloud-based service that does voice. So yeah, and then to talk about how does she work, the way that Amazon has built this thing is to use concepts like machine learning to help improve it over time. So you talk to it, it takes your audio clip, and it's like, hey, I'm going to go train off of that. And if you look in the app, there's an app for Alexa. You can say things like, oh yeah, you did the right thing, or no, you didn't do the right thing. They use that to continually make their service better. And that's kind of the advantage of having a cloud-based. They can continually improve it, they can make changes, they can do all of this stuff without you actually having to update, which is kind of nice. I feel like Alexa, or the Echo Dot anyway, I feel like it's learning stuff, new stuff all the time. Like I feel like I'll ask it random questions all the time and it won't be able to answer it one day and then the next day it will be. It's pretty cool. To start to kind of go into the Alexa skill, which is what they call these things that you do. So, I mean, I'm sure people that have the Alexa either use like a Nest skill or some sort of game where you have to go on the Amazon app and enable it. Well, those are called skills, and they're essentially just third-party things that people can build using these components right here. So an interaction model, lambda function, REST API, OAuth 2, stuff like that. So they can go in and we can set up a skill, and you can go in and like enable it, and it will be on your Echo Dot, and you'll be able to use whatever feature that comes with our skill. So I'm going to go into what each one of these things are, and some of you more technical may be familiar with REST API, obviously, and OAuth 2.0, but I'm going to go into like how all this stuff fits together, what is this stuff, and why is it important, and then I say like, these are components of a skill typically because you may not need this lambda function, which is Amazon's ability to run code when you need it. I think it allows you to run code without actually having a server, so you can do it all in Amazon, which is kind of nice. So yeah. So the first thing we go into is what is an interaction model? And the interaction model is when you're building a skill for Amazon or for the Alexa, the interaction model is how is Amazon going to take what it heard and convert it to something that your skill can consume, right? So it's like, oh, I want to order Domino's pizza. Well, you have to have the interaction model set up, the utterances and intent schema set up in order to make that work. So the first thing I want to talk about is the intent schema, right? So this is just a JSON structure that you see, and you'll see it, I'll show you guys in just a second in the developer portal what it actually is, but it's just a JSON structure that has all of your intents in it. An intent is something that you're wanting to do. So like, you can think of it more of like a command, right? So you can say, if you look at something that I have right here, this example, you've got create repo intent, create repository intent. So that's something that I can look for on my side and say, oh, when I get that create repository intent, I can do something, whatever it is that that intent does. In this case, create a repository. So yeah, that would be what an intent schema looks like. And then utterances. This is how you map up your intent to what is being said. So this is kind of hard to see. I'll have a better example in a second, but you'll have an intent, and then you'll have like a phrase of what you want to say, and then you'll have possibly slots and stuff like that. I'll go into that. But this essentially maps up, like, lists my repo intent to like the actual thing that's being said, by the person. So if you look at this, you have the intent right here, which is your, in this case, create repository intent. Some sentence that says like create repo, and then what's called a slot. Okay, and a slot is something that it's like the parameter or like the thing that it's trying to look for, like that's very specific. So in this case, I want to create a repository named whatever's in this repository name slot. So like I'll create a repository, deck talk or something like that. I'll say, Alexa, create repo deck talk or something like that. And it will say, okay. And it knows that it needs to create deck talk by pulling it from that repository name. And I'll explain why this is actually kind of a pain in the butt later. Because it's kind of a pain in the butt to code for. So yeah, with that being said, I'm going to kind of switch around here. I'm going to go into the developer portal. So when you go to work on an Alexa skill for Amazon, you'll probably start in the developer portal. This is a area that allows you to manage your skills. You can do whatever you want to. Your skill here, they literally just added the metrics feature where you can pull metrics and you can see, I don't know what view means, I've actually never clicked on that, but as you can see here, I have a live skill right now. It's called Repo Head that I built on my own. And I'll explain what that does later. It's more for engineering purposes. So yeah, if you look at what is in the developer portal, you'll see where everything's laid out. So you can say skill information, where here's the name, here's the invocation name, which invocation name is like, hey, Alexa, open blah, 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 in this case, Repo Head, right? So that's just the name that you give it to invocate. Now, Amazon, in my opinion, has done a terrible job with invocation names. Like, they don't really have, they say they enforce standards on them, but they really don't. I feel like we've run into skills in our own stuff where they have the same invocation name, and it's like, it just picks the first one, doesn't even let you choose which one. So it's got its problems. And they're very, very picky about it. It took me 5 times. I had to submit this skill 5 times in order to get it through because of nitpicky things like, oh, you can't include, a company's name inside the invocation name. That actually makes sense. Like I couldn't put GitHub helper or whatever. The skill I created was originally called GitHub helper, so it's for GitHub. But they're like, you can't put GitHub in the invocation name. So I was like, okay, that's understandable. But then there was some other stuff. Anyway, so yeah, they also have this interaction model section. So you can see where you paste the intent schema, so that intent schema we just saw earlier in the slide, that's exactly this right here. You paste it in here, you have your, you set your custom slot types. Now this is pretty important. So custom slot types are, I don't know if you'll use them very much, but if you have a slot, you have to tell Amazon what's an example of what would be in that slot, right? So list of repo names, that one's really hard to do because I was just like, well, you can have literally an infinite amount of different types of repo names. So I was just like, hello world, that was the only thing I could think of. And then like if you look at a list of privacy types, you can do public-private. So that goes back to creating public repos versus creating private repos. So like you create, those are the only 2 possible things that you could say, so I put those in there for examples. And then you've got your sample utterances. Now, I've seen where people will put every permutation of every possible utterance in here, And you don't necessarily need to. If you read it, it says example phrases. It doesn't say like try to cover everything you possibly can. Where people, you know, like it gets crazy now where people are building utterance compilers that will actually like you can put some fancy stuff in a single line and it will generate like hundreds of lines from it or something like that. You may not need that just because it's, like I said, they do a pretty good job of using like machine learning to take those examples and make them like extend them a little bit. The one thing I want to say before I continue is that one thing, we've been doing a project here, I'm not going to talk about it a lot for Alexa just because I think there's going to be another presentation for that. But we found out that it's not, Alexa is not understanding. It does not understand what you say. It only knows how to convert what you say into text or something for the skill to consume. There's no understanding there. Like that's why you could say a phrase, you can say a phrase one way and then say it a completely different way and it won't understand that those are the same phrases. So while I'm thinking about it, that's one thing I want to point out from the beginning is like, that could be a problem. Especially if you assume it understands, it gets real tricky. Okay, and then the next thing is the configuration. I won't be in here a lot, but this is kind of important. So like if you have OAuth 2.0, like if you support OAuth, or you have to have a skill linked to your account, which are people that have Echoes have had to log in at some point to like link, if you have a Nest or something like that, link your account to Amazon. Well, they have this is where you essentially do all the setups. You have your domains, your scopes, you'll have the redirect URL, stuff like that here. It's kind of boring stuff, so I won't go into this, and it's like not necessarily important, but the really important piece is this right here. This is where my Lambda function exists. You have to tell Amazon, hey, this is where you can go to call this. And then here's some, they allow you to have like test it right here. With the voice simulator, I can test exactly what how Alexa might say something. So there's something called SSML. I forgot what it stands for right now, but I will remember it hopefully in a little bit. And what it does is it's a markup language for talk, like how you can talk. So you can say like, oh, I want you to say this like this. Or like getting Alexa to say Humana actually is kind of difficult. You have to put, I forgot what those things are called. Roy, do you remember? IPA? Yeah, an IPA, yeah, sorry. So you have to put an IPA in there and say, this is how you would say this, which is kind of interesting. But you can do things like add space, you can use things called speech cons. So Alexa has all of these pre-recorded like, yippee, or things like that, and you can like put those in there, which is kind of cool. Give your skill some personality, but yeah, so you can test that out right here, and then you've got the actual service simulator where you can, type in whatever utterance you want here, and it will actually call the Lambda function and show you like how everything works. Okay, so that's enough for the developer portal. I think really the rest of it's kind of boring stuff like oh, when you want to publish, you have to fill all this stuff out, and you've got to set up the privacy and compliance stuff, and they just added this cool beta testing feature, which we already utilized. They literally just added it yesterday, and we were already jumping on that bandwagon. So that's pretty cool. So yeah, let me.
Can I ask a question?
Sure.
So you mentioned earlier that it doesn't do any natural language understanding. I know a lot of industries still working on that and struggling with that. Does Amazon give us as developers, let's say we have technology that is suited for our domain, do they give us technology that will, or do they give us outlets that we can plug in our solution and say, it's okay, Amazon, you don't have it, but we got it, we take it?
Yeah, so that was a good question. So Roy had asked, for anybody who couldn't hear that, he said, well, Amazon Alexa's not really natural language understanding, so do they give you the ability to have natural language understanding, give you an outlet for you to figure it out with another service? And the answer to that is they do, but you kind of have to it's kind of janky, is the word I would say. So you can capture you can use a slot and make the utterance map to the slot, and then, so you'll have a single slot, and you say, oh, say something, and it can be mapped to a single slot, which means everything that was said will go into that slot, and then you can pull that and send it off to a service, like a Google service, for example, because they actually do have natural language understanding, and go actually do further processing on that. Like I said, it's a little janky. I don't think Amazon recommends doing that. Actually, I know they don't, but if you want to do that, I think it's totally possible. Good question. So now I'm going to go, what the heck is a Lambda function? And here's Amazon's definition of it, but really it's running code as you need it. So instead of you having to like host code somewhere, like on Heroku or something, and waiting for a worker to spin up for the free account, because that's all I do is free stuff. AWS Lambda, you can throw it up there, and it will just start up immediately right when you need it, and then it'll shut down after it's done. It's kind of nice for this particular example. And they really push this thing hardcore when you're talking about Alexa. They're like, oh, you should host it on Lambda. There's nowhere else you can do it. That's not true. By the way, that's not true at all. You can host it on your own API or in your own domain, and just build your own API that handles it. But so yeah, like let's go look at what a Lambda function is, because I know you guys are excited about that. Woo!
Yeah.
Get pumped. All right. So here it is. So here's a list of Lambda functions. It says GitHub helper. It's not GitHub helper. That's not what I call it. I had to change the name of this thing like 5 times. There's a common five minimum step for everything you have to do. 5 minimum changes. So yeah, repo ahead, but this Lambda function is called GitHub helper, and you'll see there's a proxy function there. That's for GitHub, because GitHub's OAuth does not match Amazon, so I have to proxy it, which is not fun. So anyways, this is a Lambda function. So you can see this piece of code here, right? And all it is the index file in my Node project. So if anybody's familiar with Node or that kind of server-side JavaScript, you have an index file typically, index.js, and that's what it's loading right here. That's the only thing it loads, by the way. So do not use Lambda as an IDE, because it is not an IDE. But they do let you edit code in line, and they do let you change the color of this thing, which is kind of cool. So it's like a pseudo IDE. So yeah, so you have a handler function, and you just say, here's what the handler needs to do, and essentially all it's going to do is result, like when you get a request of this, it's just going to call it a handler function, which is kind of cool. So this is an example right here. And the way you get the code up here, which is kind of interesting, is a zip file. So if you have multiple files, you'll have to zip it up and upload it. I have a Gulp test that does this, so I'll show you guys that in a second. But yeah, so once you upload the zip, your code will show up here. You can actually run tests against it. You can say like, oh, I want you to test it this particular way, and then it will actually call the Lambda function right there and test it, which is kind of cool. The tricky part that they really don't do, I feel like, at least for me when I was looking at setting this up, is the trigger. They don't do a good job of telling you have to have this trigger, the Alexa Skills Kit trigger. And it has to be, I don't know if you see up in the top right, it says North Virginia, or in Virginia. It has to be there. Or if it's not there, you will not see this trigger. And so you can never actually use Alexa to trigger this Lambda, which kind of sucks. Kind of a pain in the butt to figure out. But once you figure it out, you're like, oh, okay, cool. And the cool thing is they do have like SDKs for this. Like you can go in, like one of the projects we're working on here, we have it all completely programmatically done. Like I can upload a Lambda function and set the trigger and recreate Lambda functions and do all this cool stuff programmatically. They actually did a good job with the SDKs on this, so it works pretty well. To be honest with you, I think I looked at the configuration part maybe one time in my whole life. You have to create a role, a Lambda role. It's like basic execution for, they do have a good documentation on how to set this part up. Like, you create a role and then you have to set the runtime and all that stuff. But yeah. I think it's like Python. Well, there you go, right there. Yeah, Python, Java, C#. I've never actually used Edge Node, but That's kind of cool. This, I think C Sharp is new. I've never seen C Sharp there before, but cool. Yeah, so there's all the other runtimes. And this is it. This is Lambda. This is Lambda from the developer or from the AWS console. And if you want to like debug these things, Amazon has a really awesome integration with CloudWatch, so you can be like, oh, I want to look at what's happening real time, like what happened when somebody invoked this thing and it blew up. You know, it's really, really awesome. So there's that. And then, as promised, let's go look at the code. This is not the code. This is LSTM, machine learning stuff. Cool. Yeah. Well, actually, I don't have any other. Hold on a second. All right, so this is repo head. So to tell you, to kind of catch back up, what is repo head? This is just a skill I worked on in my personal time, and I'm actually using it as an example now. All it does is add voice capability to GitHub. So if anybody's familiar with GitHub, it's a cloud-based, it holds all of your Git repository in a cloud. So what you can do from Alexa using this, using this repo head, is I can say like, oh, if I'm working on something locally, it's a new GitHub repo. I haven't actually pushed it anywhere yet, but I want to push it to GitHub.com. I'll say, oh, Alexa, go create repo deck talk, and it'll say, okay, I'll go create it for you. And then you have like a repo that exists in Origin that you can push to. So it just allows it just to make things easier. That was the biggest use case for me. And then what you can do is add. You can look at latest commit, so I can say, what's the latest commit for dependency binder, which is another open source thing I created. Or I can say, tell me what repos I have, and it will list all of your private and public repos for you. And I think that's pretty much it right now. And I'll tell you about some of the features that I'm wanting to add later. So yeah, as you see, we got our intent schema. Utterances, I don't think I need to go back into that, but here's like a full list of the utterances. So like you can see the create repository intent, see how to say, oh, to create privacy repository, so you can say, Alexa ask repohead to create public repository blah. So it's kind of cool. Yeah, so like I said before, you have an index file, and you'll have which has the handler, which is what we saw in AWS Lambda. And then inside there you'll use something called, which I have it creating in a what I call a factory. Find it real quick. So it's creating a new instance of repo head. Repo head is a module over here that essentially pulls in, it extends the Alexa skill. So you can see repo head, I know all of this stuff is boring. I'm going to get to the meat and potatoes here in a second. But you can see that it's extending Alexa skill. And Alexa skill is the important part. So I love that little copyright thing up there because this is what Amazon uses for when any of their examples. They have a ton of examples online. And this is like, if you want to get going, you just copy this Alexa skill and get going. It does a good job at handling everything. So you can see that it sets up request handlers like launch request and intent request. So there's a difference between launching a skill and then just saying an intent, right? So when you say, there's a concept of launching, which is open, Alexa, open repo head, that's launching. Or you could do what's called a straight shot. And a straight shot is, Alexa, tell repo head to create repository blah. So both of those work for repo head in this case, and I think a lot of other skills support that, but that's where you get into these request handlers, right? So you have launch requests and then intent requests. And then you've got other things like event handlers where you can say, oh, I want to do this on launch, I want to do this on intent, I added one that's called on invocation. So every time you invocate with this thing, like you're like open blah blah blah, or create repo head, create repo, whatever, it's gonna run this event right here at the bottom that you can't see, sorry. Right here. They're empty right now because I override them in the repo head, which is back the previous class. And then this is the execute function, so whenever you get whenever you get a request, I don't know if you remember the Lambda, let me go back to the index. It calls execute with an event in context, and inside that context, actually it's inside the event, there's a session property, and that session property's got everything about your current session. So like, if I join it with OAuth, it'll have my access token, so I can call another service. So I can call GitHub's API and it knows who I am. Or it's got my user ID where I can say like, oh, this is the user that's associated with this request. And it's got a bunch of other stuff. An example I could possibly show you, hopefully it's pretty quick, would be here. I could be like, hey, open repo head. And I can be like, oh, that's the wrong spot. Cool. There we go. Open repo. And then I said, ask repo head. So that was the launch request. And as you can see, I got the stuff back here. So I've got session, it's got session ID, it's got user, it's got my user ID, my access token, whether this was a new session or not, and then it's got some information about the request. Here. So like, you know, I don't know why it's a list all my open issues, but there, you know, there's some information there about what has happened there. So yeah. Oh, it's probably because I said open read head instead of repo head. Sorry about that. You guys know what I meant. That was a launch request. It should have said open repo head. It would have came through as a launch request there, but that was my bad. Anyway, so yeah, so you'll have these event handlers, intent handlers, request handlers that you can override and you can set them to do specific things. So one thing I wanted to show real quick before we jump off here is this is the intent handlers, right? So this is whenever you get an intent, it's going to show up in that request, like if you saw right there, list all my open issues. That's going to get passed all the way down to the intent handlers, and then you can use that to look up the function that it's called. And you can see, like I'm saying, like, oh, request handler, handle list repository request, and it does its thing. And yeah, so to take us a couple steps back to what I was showing you earlier, I can possibly pull it up here. This right here. So remember I said this can be kind of a pain in the butt earlier? Well, I'll show you why it's kind of a pain in the butt. So I'm going to show you this class called, this module called string matcher. And it uses this algorithm called iterative Levenshtein distance, okay? And the reason why it uses this algorithm is because whenever I say, if I were to say something like, in that example, it's fine, creating repos is fine because you could say, create whatever. But if I wanted to look up a repository, if I said, tell me about dependency binder, or an actual repository I have is OTMF microlocation, so for one of the other projects I'm working on at home. So if I said, Alexa, what's the latest commit for OTMF microlocation? It's going to say, oh, you said ODMF microlocation? I don't have that. What repo is that? I'm just gonna fail because I just passed ODMF microlocation to the service, and you don't have a repo named that. So this is just a clever way of getting around it, right? So I could say, what this algorithm does is it says, all right, I have a string, I have a ODMF microlocation, and I know all of your repositories. So like I already have a list of all your repositories. I'm going to compare that string to every list or every repo name inside the list, and I'm going to calculate how many changes does it take to get to the string that I have now. And the least amount of change, the string with the least amount of changes will be the one it selects. And it does work, but as you can see, it can be very inefficient if you have a ton of repos. Especially if you were to say, hey, I want to open this up to every public repo on GitHub. That would be dangerous. That would not be good. So one of the ways I'm trying to fix this right now, I was hoping to have done before you guys this time, is using machine learning. This is a good case for predictive modeling. So I could say, here's what you said, here's what I think it is based off of some training I've done. And so I'm working on a LSTM now to get this very thing working. unfortunately I couldn't get it working. I got the generative model working, which so was generating repo names, but I couldn't get the predictive model working yet. So the idea would be is I would pull every repo down from GitHub, which I did, and I'm training this thing off of every repo, and it's going to try to guess based off of what Alexa heard, what repo are you saying? And the reason why this is so powerful is because I can now open this up to every public repo. You can ask it literally about any possible, like any repo that's public in GitHub, which is kind of cool, especially because there's like millions of them. It's kind of crazy actually. It takes a really long time to pull that down. So yeah, that's kind of the issue, and that's the way you could remediate it. That's the way you could use machine learning to solve that problem. Let me check and make sure. I want to save some time for questions if anybody has any. Yeah, so to go back, I want to just touch on this real quick. Alexa's powered by AVS, right? So there's something called AVS, which is Alexa Voice Service, and this is just a service that you can hit with anything. So I could load it onto my Raspberry Pi that I have and call Alexa and make it Alexa voice enabled, right? Or I could put it in my car or in a speaker. I mean, I was reading something they were talking about putting it in cars, which is kind of cool. So yeah, that's all I got. Does anybody have any questions?
Can you show us the skill working?
No, I'm just kidding. Yeah, I can show you the skill working. I don't know. I just linked the account to my GitHub just a second ago, so I wasn't up here earlier. And I don't. If I hook this up to sound, will it go?
Yeah.
All right, let's hopefully get this.
You may have to switch it over to VGA, but yeah, if you just switch it over. Yeah, that should.
All right, let's hope this isn't super loud. Alexa, open repo head.
She's talking, you barely hear.
Yeah. Is there volume? Can I turn it up?
Should be right there on the right.
Right here?
Yeah, that's be your volume too, so be here.
Blog posts, which is private to you.
Oh.
Dependency binder.
So I thought I said.
GitHub repo graphic.
Alexa.
Vector.
Stop. Yeah, you don't get used to saying that a lot. I'm trying not to blow everyone's ears out. Hold on. So yeah, so let me try that again with you guys, where you guys can hear it. Alexa, open repo head.
Hi, Cody. Repo head here. What can I do for you?
Create public repo deck talk.
I can help with doing things such as creating a repo or checking latest commit. What can I do for you?
Create public repo deck talk.
There is currently no open issues assigned to you.
It works better. It works better than this. I don't know what's going on here. Let me try this one more time. Hold on. Alexa, open repo head.
Hi, Cody. Repo head here. What can I do for you?
Create public repository deck talk.
All right. I created deck talk for you.
All right. So now, I can show you real quick. Don't do it with my GitHub handle. It's kind of silly. Deck talk. Now it's obviously not deck as we would think DEC, but it's deck talk. So yeah, like. And you can do this with public and private repos. And that was just one of the examples. This example is the most useful for me. And when I'm working, I put this thing right in front of me, and if I'm creating a repo, I can say, go create this repo, and then I can send a remote, like from the keyboard. I don't even have to worry about going into GitHub anymore. But there's other things you can do with it. You can say, like, what's the latest commit for dependency binder? So it's cool if I show you guys that. Good. Alexa, open repo head.
Hi, Cody. Repo head here. What can I do for you?
What's the latest commit for dependency binder?
The latest commit for dependency binder is added license made by Cody Hutchens.
So like, I can say like, I can go through all my repos, find out what was the latest commit on them. There's other things that you could possibly do with this, as like doing pull requests, like actually seeing those through, and then you get past that problem, it's actually pretty useful. But do any of you have any questions?
So how long did it take you to create the skill?
3 weeks.
Wow.
Yeah. Like GitHub made you guys pretty good. Now submitting the skill was a whole separate issue. That took like an additional 3 weeks because that's just the way it works. Amazon rejected me 5 times. So yeah. Because they actually, all those utterances and all those intent statements, they actually go through every single one. They have to be working, which means I have to give them my account info and they have to be able to create repos. I was getting all sorts of crazy, weird repos showing up on my GitHub account. So yeah. I got this free hoodie I decided to wear. So they're giving away free clothes if you submit a skill. I mean, you can't beat that. I just got a $100 AWS credit too. So like,
Too fancy.
I mean, they're free stuff, man. I do what I can.
So what are the rules around that, including a company name? It's like, they obviously have like a Domino's ordering pizza.
Well, the rule is that you have to own the copyright. So you have to own the copyright to whatever name. So like,
But what if you're using like other integrated technology, like if there's a TFS skill?
oh, yeah. So you have to get with you would have to get with Microsoft, and they'd have to be like, oh, yeah, it's okay that you did that. So for example, they told me I had to reach out to GitHub and ask GitHub to okay this, whatever. Because even in the description, I had it next to your GitHub account. And they were like, no. So that's why I had to change it to, if you look in the description, it says cloud-based repo, whatever. It says, it has the definition of like what is GitHub. So yeah, like that's the way I had to get around that. And then for even Git, like even use Git, I had to reach out to Git, and they never responded back to me. And so I was like, all right, well, Git's no longer the name either. So that's why I repo it. Yeah. Any other questions? Matt.
This might get a little bit into like feasibility, but we talked about it doesn't have natural language understanding. How does that limit you? How does the structure of utterances and how it actually handles language limit you from development perspective on like what you're capable of doing?
I would say that you have to try to understand what they're going to say to Alexa. That's the whole problem, is that Alexa can't just handle it. Saying different variations. You have to try to account for as many of those variations as you can. You don't have to account for every, but you have to account as many of those as you can. If you don't know how the person is going to use the skill, they could use it a completely different way than you even thought. Then you're going to run into like a lot of problems there. You have to like try to, figure that out, I guess, on your own. But for me, it wasn't really that big of a deal obviously for this. But
I mean, basically, all the variants have to be pre-mapped. It's not like it's going to figure something out.
Exactly.
Everything's got to be in the matrix that you built for this thing.
exactly, yeah. Does that, you feel like that answer your question?
They give you a list of the utterances that have gone into it. So like when you're using it, if you said, build me a repo.
Yeah. So, like, are you saying like, does the skill show you what's possible? Like, what are the
So if you were using it, so if someone was using it in a way you didn't expect, is there a way for you to pull up the report showing the commands that are going to it?
Kind of. You kind of have to build it to do something like that, right? So you could have an unknown intent, catch those, and say like, oh, I got this many unknown intents, but you have no idea what they said. So like, Amazon does not give you access to what they say unless you do that key slot thing I was talking about, where you make the intent like the slot. Then you can capture. No, you can only log the intent that was triggered. And I think even their metrics are only on the intent level. They're not even on the utterance level, like what actually was said. You can hear what you said by playing it underneath the card, because you get these things called cards, and it will actually show, here's what you said. You go back and play it, but we don't have access to that. But maybe they will add that, I don't know. Yeah.
Google. I mean, primarily because I was a Prime user, Amazon, all that stuff. I do think the natural language is definitely stronger in Google, but it looks like Amazon's really pressing on integrations for Alexa, smart door locks and all kinds of other Nest, thermometers and stuff like that. So I think it's going to be a matter of not just what's the, as far as market penetration, it's not going to be just how talented is Google,
Right.
what's going to be the suite of integrations that I can get off the shelf.
Right, or like what can I do with this thing? Like can I plug it into everything, allow everything to be voice? Yeah, I totally agree with that. The cool thing about Google though, they're integrating things heavily with their assistant. So like the assistant I have Google Home as well as an Amazon, and I love Google Home. It handles things so much better than Amazon does. Amazon's obviously getting better, but Google, in my opinion, handles things better. But I told my Google Home what my fiance's name was, and it was like, okay, I'll remember that. And then I asked my phone, what's my fiance's name? And it was like, oh, here you go, your fiance's name is Alicia Dennison.
That's pretty cool.
And I was like, they're like integrating that kind of like holistically across things. So I don't know if like, I don't know.
Can you ask Google to teach Alexa that?
That